The universe is enormous, but to what extent? People have been staring at the sky for millennia, wondering how big the universe really is. Through the development of the first telescopes and the powerful Hubble, we have expanded our knowledge. However, the incredible vastness of the cosmos is now becoming more visible with the launch of the James Webb Space Telescope. Astronomy is entering a new age with the James Webb Space Telescope, which is frequently heralded as the Hubble Space Telescope's replacement. Launched on December 25, 2021, it is a feat of contemporary engineering, featuring an orbit that is 1.5 million kilometers from Earth and a mirror that stretches over 6.5 meters. Webb is built to look farther into the cosmos than any previous telescope. Webb concentrates on infrared observations, in contrast to Hubble, which mostly observes in the visible and ultraviolet spectra. This gives it the ability to see through gas and dust clouds to expose items that have never been seen before. By using this power, Webb is able to reveal the mysteries of the early cosmos and give us a more accurate understanding of its actual size. The James Webb Telescope has already returned amazing, unimaginable sights since it was launched. Each image offers more than just breathtaking scenery, ranging from far-off galaxies to places where stars are formed. These are facts that contribute to our understanding of the size of the universe. The amount of information Webb has discovered thus far is simply amazing. Beyond merely being a technological marvel, the James Webb Telescope's emphasis on the infrared spectrum has fundamentally altered our understanding of the cosmos. Because infrared light has longer wavelengths than visible light, Webb can see areas that have been obscured from view by peering through clouds of cosmic dust. For instance, star-forming areas covered in thick gas and dust clouds are almost completely opaque to visible light. However, Webb can see through these clouds using infrared, allowing him to witness the formation of stars and planetary systems. These photos give us important information that advances our knowledge of the mechanisms underlying star formation and, eventually, the emergence of new solar systems. Webb discovered the Eagle Nebula's Pillars of Creation, a star-forming region, during one of its earliest investigations. The infrared photos emphasize the complex structures of gas and dust that drive the birth of new stars, presenting an unprecedented amount of detail. The James Webb Telescope has yielded some of the most significant findings regarding the universe's expansion. Although the cosmos has been expanding for decades, Webb's discoveries are giving scientists fresh understanding of this phenomenon. Webb is assisting scientists in measuring the pace of expansion with previously unheard-of accuracy by observing far-off galaxies. This affects how we think about dark energy, the enigmatic force responsible for the universe's accelerating expansion. One of the greatest mysteries in cosmology is still dark energy. Despite making up roughly 68% of the cosmos, we don't know much about it. In order to create new ideas and models that may explain the nature of dark energy and how it influences the expansion of the universe, scientists need Webb's data. In this sense, Webb's studies of far-off supernovae, exploding stars that act as cosmic yardsticks, are especially significant. Through analyzing the light emitted by these supernovae, researchers may ascertain the rate at which the universe is expanding and improve their calculations regarding the impact of dark energy. The cosmic dawn, the early stage of the cosmos, is being better understood thanks to the James Webb Telescope. This period, roughly 200 million years following the Big Bang, is credited with the initial production of stars and galaxies. Understanding how the universe changed from a hot, dense state to the wide, complex world we observe today requires an observation of this time period. Because of its infrared capabilities, Webb is able to observe some of the first galaxies to develop. Due to billions of years of cosmic expansion, these old galaxies look as hazy smudges of light. Scientists can discover more about the early universe's circumstances and the formation of the first structures by examining these galaxies. The discovery of extraordinarily big and mature galaxies in the early cosmos is one of Webb's most important discoveries. These galaxies defy current assumptions about how quickly galaxies may form and evolve because they were generated only a few 100 million years after the Big Bang. This has raised intriguing new issues concerning the nature of galaxy development. The James Webb Telescope is assisting us in our quest for extraterrestrial life while simultaneously illuminating the size of the cosmos. An important instrument in this search is Webb's capacity to examine the atmospheres of exoplanets, or planets circling other stars. By examining the light that travels through exoplanet atmospheres while the planet orbits its star, Webb is able to determine the chemical makeup of these environments. Scientists can detect the presence of gases like water vapor, carbon dioxide, methane, and even oxygen using a method called transmission spectroscopy. These gases are all possible markers of life. Finding water vapor in the atmosphere of a far-off exoplanet that is in its star's habitable zone is one of Webb's most remarkable findings. The area surrounding a star known as the habitable zone is ideal for looking for life because it may have the conditions necessary for liquid water to exist there. Even if conclusive proof of life beyond Earth is still pending, Webb's observations are getting us closer than ever. We are beginning to address the age-old question: are we alone in the universe? By examining the atmospheres of exoplanets and identifying those that may support life. Among the universe's most enigmatic and captivating things are black holes. Scientists have long been interested in these areas of space, where gravity is so intense that not even light can escape. We can now see black holes and their surroundings like never before thanks to the James Webb Telescope. Capturing the supermassive black hole accretion disks is one of Webb's major accomplishments. Massive amounts of energy are released by these gas and dust disks as they spiral into the black hole. Webb is contributing to our understanding of black hole growth and its effects on neighboring galaxies by examining these disks. Furthermore, Webb's findings are illuminating the intricate relationships that exist between black holes and their surroundings. Webb, for instance, has recorded high-energy particle jets that are shot out of black holes at speeds close to light. These jets can control star formation and sculpt the cosmic landscape, having a significant effect on neighboring galaxies. We are learning more about the large-scale structure of the universe as we use the James Webb Telescope to investigate the cosmos. The universe is structured like a massive cosmic web, with filaments of dark matter linking galaxies and clusters together, rather than being a disorganized collection of galaxies and stars. Scientists are mapping this cosmic web more precisely than ever before thanks to Webb's discoveries. Webb's research on the distribution of galaxies and dark matter is yielding fresh insights about the formation and evolution of the universe's structure over billions of years. The discovery of massive galaxy clusters, some of which are billions of light-years away, is among Webb's most remarkable findings. These clusters are some of the largest structures in the cosmos, made up of thousands of galaxies. Scientists are learning more about the formation process of these clusters and their impact on the surrounding cosmic web thanks to Webb's observations. The James Webb Telescope has only just begun to yield findings. Undoubtedly, as Webb carries out its job, it will solve more riddles and offer fresh perspectives on the actual size of the cosmos. Webb will concentrate on a range of scientific objectives in the upcoming years, including measuring the distribution of dark matter and researching the atmospheres of exoplanets. To build a more comprehensive image of the cosmos, Webb will collaborate with other observatories and telescopes, including the soon-to-be Nancy Grace Roman Space Telescope. It's obvious that the James Webb Telescope will have a significant impact on how we perceive the universe in the future. Its findings will inspire upcoming generations of astronomers, scientists, and explorers in addition to advancing our understanding of the cosmos. To sum up, the James Webb Space Telescope is completely changing our perception of the cosmos. Webb is a tribute to human curiosity and inventiveness, having discovered the astounding number of galaxies and revealed the mysteries surrounding dark matter. We are reminded that the cosmos is far bigger, more intricate, and more exquisite than we could have ever dreamed when we stare into the abyss. Keep checking back as the James Webb Space Telescope continues to unveil the mysteries of the universe and demonstrate that our understanding of its true size is still developing.